All right, here we are ready to tackle the next part of section 7. And we talked about distributive property yesterday. So now we're going to talk about more properties or different kinds of properties that you've got. All right. So in your notes, make sure you've got section 7b. And here we go. Today will be kind of short. I'm sure you'll appreciate that. Not that you just don't enjoy love. Listening to me and loving math all the time. All right, so here is your learning target for today. I can simplify expressions again using mathematical properties. I'm just going to say math properties, okay? Da da da, diddly ding, toon toon. Here we go. Ready? All right, first one is called commutative. Commutative. Have you ever heard someone talk about how they commute to work? Okay, so that means you're going from your house, you're driving somewhere to work, and then you come back. Okay, it's back and forth and back and forth and back and forth. Well, in math, the commutative property, so right under this word commutative, I want you to think this: switch the order. Okay, and I like to be kind of brief with my terms, so say switch the order. Okay. And I notice that I've got two operations here, adding and then this dot, which represents multiplication. That's because commutative property works for addition and it works for multiplication. Let's just pick any old two numbers at random. So let's say 16 and 9, okay? And if I said, what's 16 plus 9? Say, well, that's 25. Yep. And then what if I said, what's 9 plus 16? You'd say, duh, it's 25. That's right. The order doesn't matter. I get the same end result. They're both equal to 25. Algebraically, here's what it looks like. If I pick any two old variables like L and B, and I say, hey, if I told you to add those two together, it would be exactly the same as saying take B plus L. So algebraically, here's how it looks, the commutative property. Changing the order doesn't matter. The same thing works for multiplication. If I said, hey, let's just pick two numbers here, like 7 and 9, if you took 7 times 9, you'd say, oh, well, that equals 63. And if I said, well, what about 9 times 7? Well, that's still 63. You're exactly right. So what happens here is, once again, the order doesn't matter. I can switch the order and still get the same value. So algebraically, the way we kind of write or demonstrate this property is if I take, let's say, y times z. Y times z is going to be the same as z times y. There you go. Okay, that's the commutative property. Then comes this one, associative. The associative property, and I want you to think of this underneath here, has to do with grouping. Okay, you can change the grouping and you're still going to end up with the same value. So sometimes I say just illustrate that by putting parentheses there. Okay, so let's think about 3 numbers this time that we're going to add together. Like what about 3 and 4 and 8? Okay, and I am going to say, I'm going to group the 3 and the 4 together first. Order of operations says, hey, parentheses first. So this would be 7 plus 8, which is 15. Okay. Go back and write down 3 plus 4 plus 8 again, but this time let's put the parentheses around the 4 and the 8. that says, hey, do the 4 plus 8 first. Well, 4 plus 8, that gives me 12. So then 3 plus 12 is 15. You see? Even just regrouping it using this property called the associative property, you still get the same result. So algebraically, how do we demonstrate this property? I would say let's use A plus B, that quantity in parentheses, plus C, ABC. That is going to give you the same answer as A plus, in parentheses now, the quantity B plus C. Ha! Notice the order stayed the same, A and then A, B, C, and on the right-hand side, A, B, C. But I simply switched the order of the parentheses, or switched the placement of the parentheses, and it turns out you still get the same value in the end. So the associative property works for addition. Psst, guess what? It also works for multiplication. Let's get a couple numbers like 2 and 5 and 4. Okay? 2 and 5 and 4. If I tell you group the 2 and the 5 together first, that means I do 2 times 5 is 10. 10 times 4 is 40. Okay? What if I said, instead of 2 times 5 first in parentheses, let's do it this way. 2 times 5 times 4 in parentheses, that's 20. And then 2 times 20. Hey, it's 40 again. It appears as though this property works for multiplication too. You're right, yes it does. So, algebraically, I could write it like this. Let's do Q times R times S. Okay, and if I have the grouping symbols around the Q and the R, it also will be true to take Q times then the quantity R times S in parentheses. Notice the order is the same, Q, R, S, Q, R, S, but I've grouped them differently. You will still get the same answer. All right? Commutative, switch the order. Associative, change your grouping by moving your parentheses. Last one, and we just talked about this, is the distributive property. Okay? The distributive property, and you can go forward and backward with it basically, tells you that you use it with usually adding and subtracting and a multiplying or a dividing. So let's illustrate it this way. I'm not even going to write any words here, except maybe I would put the good old like Angry Birds arrows here to kind of illustrate what's going on. 3 times, in parentheses, let's say 4 plus 9 or something like this. Okay? This, now normally you would say, well, 4 plus 9 is 13, so then 3 times 13 is 39. Okay? Yes, but it's also true that I could take 3 times the 4 and 3 times the 9 using the distributive property, and I'll also get 39 because 3 times 4 is 12, 3 times 9 is 27, 12 and 27, 39. You get an equivalent statement, okay? If I wanted to write this algebraically, let's do this. No, I'd used K in the last one, didn't I? Yeah, no, I used Q. So let's do K, M, and N. K times M plus N is going to be equal to K times the M plus K times the N. Okay? Awesome. Awesome, awesome, awesome. All right, these are your 3 properties that you can use. Keep in mind, it works with algebraic statements. We wrote it kind of an algebraic law, but one thing I do want to show you, and I know this isn't in your notes because it's just coming to my head now. If I gave you something like this, 4 times 3x plus 5, something like this. And I said simplify it. You can distribute, because see, 3x and 5 I'm not going to be able to combine together. So I get 12x and then plus a 20. Okay. You could also go backwards. If I gave you a 12x plus the 20 and I said, what do these guys share as a common factor? You'd say, well, the 12 and the 20, they share a 2. They both share a 4. 4 times what would give you 12x? Go, well, that'd be 3x. And then 4 times what would give you 20? This way. So you can go forwards and backwards with that distributive property. Just want you to see that. This is actually a way to factor this algebraic expression, and we get to do that in about chapter 8 and 9. Cool. So there's a little preview. All right, well, here's what's happening today. Let's take a look at some of these examples now. 1/3 times 5 times 33. Okay, now, order of operations says, yep, you should just go left to right. But you know what? Now that I know these properties, hot diggity, let's make use of the commutative property to say, hey, I would really rather take 1/3 times 33. So I'm going to flip-flop the order of these guys and then multiply by 5. You know why? Because 1/3 times 33, I can do some simplifying here. 3 goes into 33 11 times. 1 times 11 is 11 all over 1, and then times 5 is 55. Much easier. Let's do another one. Ooh, here's a big long string of addition. Okay? No, I don't want to go left to right on this one because I know I can use commutative and associative property to make this a lot better. Here's what I'm going to do. I'm going to use commutative property here to say 410 plus 90, then plus 58 plus 2. And then I'm going to use the associative property to say, let's do these two together. Yes. And let's do these two together. And now I get 560. It's a way more efficient way than taking 410 plus 58. That gives me 468. And then add 90. And then you get like 558. And then add 2 more. It's way easier if you find the easy ones that have 10s in them when you're adding. Now we're cooking with gas. All right, here's your job. Your assignment today, because we don't have anything specific just in our textbook for this, is I want you to jump on to IXL and work on these 3 objectives, R8, R9, R10. Get to a SMART score of 80 or higher, and then move on to the next one, and so on. All right, good luck. May the force be with you.